Okay, find a vector that's in the same direction as 3, -2, but with the same magnitude as 1, 4. So I'm going to draw the magnitude 3, -2, so we know what we're talking about here. Okay, and I'll name, that's vector U, I'll call that. And then vector V, do that in pink, 1, 4. All right, so first I'm going to find out the magnitude of V. So that's going to be this guy plus 4 squared. So that magnitude is going to be the square root of 17. So our vector's got to have a magnitude of 17. For direction, I know we can do like angles and stuff, but what I kind of want to do here is look at the components of U. So we're going over 3 and down 2. I know it's a -2, but I'm just going to know that that negative puts my vertical component going downward. Now, if I want my vector to be in the same direction, I know that it has to keep that ratio of vertical to horizontal component. So in other words, let's say, I don't know what magnitude this is, but let's say we make ours W. The ratio of A and B, my two components for vector AB, okay, we'll call that one vector W. That's our vector that we're going to find that meets those two criteria. I know that the ratio of A to B has to be equal to the ratio of 3 to 2. And I'll deal with direction later. I don't need that -2. I just know my orange triangle's got to have that same ratio, because those are similar triangles if they're going in the same direction. That's how I'm going to think about direction. Okay, so I know that the magnitude of W has to be root 17, and I know this ratio needs to be true. So I'm thinking with these two pieces of information, I can do a system of equations. That first equation will be the magnitude of W is going to be A squared plus B squared, the square root of that. That needs to be equal to root 17. If I square both sides, I arrive at that equation. I also have this equation up here about direction. So if I solve for A, I'd multiply both sides by B. So I've got two equations here. I've got this guy and this guy, so I'm going to solve that system. So I'm going to take, I solved for A, I'm going to plug that into this other equation here. So I've got 3/2 B squared plus B squared equals 17. So then if I square, if I square that, I get 9/4 B squared plus B squared equals 17. And now I can solve this equation for B. So this is like 4/4, right? So I'm going to add those together, and I get 13/4 B squared equals 17. I get B squared equals 4 times 13 times 17. So then I get essentially B squared equals 4 times 17 over 13. There's a reason why I'm not multiplying the 4 times the 17. When I square root both sides, I'm going to get 2 times the square root of 17 over the square root of 13. I can write it like that. There's all different ways I can write it. I'll leave it like that for now. Now remember, that's B, and I know that when I write it in my vector, B is going in the negative, right? That's going in the negative vertical direction. So as I write my vector, it's going to be a -2 root 17 over root 13. That's going to be the vertical component of my vector. How do I get the horizontal? I'd probably go back to this equation up here and rewrite that, solving for a, where I plug in my b. So it's 3/2 times 2 root 17 over root 13. So a is going to be, the 2's would cancel. I would get 3 root 17 over root 13. And that is going, oops, I wrote that backwards. That is going in the positive direction. So that's 3 root 17 over root 13. If I were you and this were a quiz, I would use that vector now and make sure that it meets both criteria. I would make sure the magnitude is root 17, and I would make sure that it's going in the proper direction.